now on page 2, and we're going to do a few examples together solving for formal charge of atoms in a Lewis molecule. So I first want to point out that the structures on this page are covalent bonds. So remember that the lines in these structures represents a bond, and each line is 2 shared electrons. So what we're going to be doing is analyzing these Lewis structures and solving for something called formal charge. Formal charge is useful for determining which of these structures, 1, 2, or 3, is the best representation of what the molecule really looks like. And so what we're going to do is assign formal charge. So the steps 1, 2, and 3 up here show us how to calculate the formal charge of an atom and a molecule. So for each atom, we're going to take the original number of valence electrons in the atom. Then we are going to subtract 1 for each bond that's on that atom. So I like to say that each bond is just a line. Okay, so for every line, we subtract 1. And then we also subtract 1 for each dot, which, remember, represents an electron. So the formula for formal charge is valence electrons minus lines minus dots. Rule 4 here tells us what formal charge is used for. The best structure has a total formal charge closest to 0, the charge of the entire structure. And if there's a tie, then you want to pick the one that has the most zeros. Okay. If there is a negative charge on the structure, for instance, set number 2 has negative charges on the structures, then the best choice would have the negative charge, the negative formal charge, on the most electronegative element. So what we're going to do here today, though, is you do not have to do steps 4 and 5 without me. So if I'm not there today and you're working on this on your own, I simply want you to solve for the formal charge of each atom in each molecule. So let's take a look at how this works. So we're going to look at each atom individually. So let's first look at the oxygen on the left. So we're going to take its original number of valence electrons. For oxygen, that's 6. Now we're going to subtract the number of lines attached to that oxygen. Well, it's just 1. It's this guy right there. So we're going to subtract 1. And then we're also going to subtract the number of dots that it has around it. So there's 1, 2, 3, 4, 5, 6. So we're going to subtract 6. So the formal charge of this oxygen is 6 minus 1 minus 6, which is negative 1. That is the formal charge of that oxygen. Next up, let's solve for the formal charge of this carbon in the middle. So carbon has 4 valence electrons. We are going to subtract 1 for each line attached to it, and this carbon has 2 lines. And then we're going to subtract for each dot on the carbon. Well, there's no dots on the carbon, so that's 0. So the formal charge of that carbon is positive 2. Formal charge can be positive or negative, so I like to write which one it is instead of just writing 2. All right, this oxygen here on the right, you will notice that it's the same as the oxygen on the left. It's just mirrored. So it's 6 normal valence electrons in oxygen minus 1 line minus 6 dots, and the formal charge is negative 1. All right, I'm going to suggest that you pause this video and then try to solve for the formal charge of the carbons and oxygens in these other 2 structures, then hit play and come back to check your work. For the middle structure, this oxygen on the left is 6 valence electrons minus 2 lines minus 4 dots, formal charge of 0. The carbon in the middle is 4 valence electrons minus 4 lines minus 0 dots, so formal charge equals 0. The oxygen on the right is 6 valence electrons minus 2 lines minus 4 dots equals 0 for the formal charge. This structure is looking good because all of the formal charges equal 0, so the total equals 0, and that is usually the best choice. I'm going to go ahead and spoil it, and I'm going to tell you that this is the correct structure of this molecule. And I even want you to write above this molecule the word famous. This is a famous and commonly used example of a covalent compound, and this is actually carbon dioxide, the gas that you're breathing out right now. So just label it as famous. The more you see it and the more you think about it and the more you know it, the better off you're going to be. The final one to analyze, the carbon dioxide structure on the right. Oxygen has 6 valence electrons minus 1 line minus 6 dots. That equals -1. The carbon in the middle has 4 valence electrons minus 4 lines minus 0 dots, has a formal charge of 0. And the oxygen on the right has 6 valence electrons minus 3 lines minus 2 dots equals a formal charge of +1. So again, if we look at all three of these structures, the best option is the one that has the total formal charge and individual formal charges closest to 0. So this is the best structure. If you are working on the rest of this page on your own, I want you to simply identify the formal charge of each atom and then move on. I don't want you to try to analyze which one is best because I edited some of these molecules and they are not even real. So just assign formal charge for each atom in each molecule and move on.